In this video, we'll walk through the code of using a simple input array statement to give the user the ability to navigate within a set of data, as you see here on the screen, make changes to that data, and manage the way they work within these columns and cells in manipulating this data. One of the things you'll note when in an input array versus a display array is that we have automatically the boundaries or grid sort of format on the table container, and we can enter any of the fields to add some additional data. And as we move from field to field, different control blocks are being executed to manage what happens with the changes that the user has made. We also have over here a set of default actions that are built as part of the input array, and you can control these as well, but just to see how they work, if we chose insert, you'll notice that a new row is inserted into the array, into the screen array, and we can go ahead and add the data that we want to include. And as we leave the field, that data is actually inserted into the database. We can also append, which will just append to the array on the last line here. And again, we can add our data and navigate around making any changes that we want to make to this data in any of the rows. Now once we've done that, we can also of course delete. If I put my cursor down here in the one that I added, called a new store number 2, I can choose delete, and I'm choosing to delete the row, and it no longer appears in the table, and it has also been deleted from the database. Okay, so let's go ahead and take a look at the code that implements this, and recognize too that you can certainly customize a lot of what's happening here in terms of if you want to highlight where the user's cursor is as they move from cell to cell. Again, and using the control blocks we'll look at, you can manage exactly what happens as they are moving through and working with the data. In this one we have two files. We have a form, the custall form for AD, which as we can see here has the name gr2. And if we look at the form structure, we'll see very similar to our last example. We have the table container as well as the screen container, and the grid container was gr2. The name of our screen record is sacust, and the name of our table is sacust here. All right, now if we look at the 4GL, the source file, we see that we have a record defined. This record is defining a number of different columns, and we have a dynamic array defined. And in this program, the first thing that's happening is we are connecting to the database. We're opening a new window with the form, and we're calling a function called load custall, returning IDX. Now IDX was just defined up here as an integer. We're going to use IDX to determine at first if any rows were loaded into the screen array or not, or if there were any rows in the array to work with. So we'll go ahead and call load custall, and if we look at load custall, we'll see that it is the function that is declaring the cursor. And here we're going to order by store num, so that will be the way in which we receive the data. We're clearing the array, and again we're doing a standard for each loop as we did in the display array example to simply fill the array with the data from the result set. Now if there aren't any rows loaded, we're going to return 0, but if there were, we're going to return the length, so the number of rows that we filled in. So we know the length of the array, and we pass that back to the calling function. Now once we've done that, we're going to call input array custall, and this function is going to take us into the input array. So at this point we have loaded the array, filled the array with the data from the result set, and now we're going to specify input array, the name of our array custar, without defaults, from SACust, and we want it to be unbuffered. Now you'll notice in this example there are a lot of control blocks being used to manage how the user works within this input array dialog. So for example, before input, we're going to give them a message about how to accept and cancel. Before row, so as they are entering a row, before they get a handle on that row, we're going to set the current position in the array, our own little small int integer here. We're going to set it to the built-in function rcur, and rcur is set to the current position in the array. So this is a built-in function we can use to learn what is the current position in the array. Now we'll come back and talk about these operating flags in a minute, but let's just look at these control blocks first. Here's one that's a before insert. So before the user gets access to the new row that's been opened with that insert action. After insert, before delete. So before we delete the row, what is going to happen? And here we're going to actually call a function called deleteCust. On row change, if the user has changed anything in the row. Before field, on change store num, etc., etc. So lots of different control blocks allowing us to manage how the user interacts with this data. Now let's go back up and talk a little bit about this op flag. One of the key important parts of working in an input array is recognizing what the user is doing, and if they have confirmed a change that we need to then pass to the database. So because the user can jump from cell to cell and can make changes as they're moving in and out of fields or in and out of rows, we are going to keep a little bit of a flag system to identify exactly what we need to do or what we need to pay attention to on that particular row. So before row, we set the operating flag to N. You might think of this as N or new, and you could have your own system for managing how the user works within your input array. So N is new, neutral, nothing except that we know that the user has entered a new row. Before insert, we're going to set it to T, or temporary. So before the insert, before the row is open, we're setting it to temporary. After they've inserted, in other words, they confirmed the insert by putting in data and moving off of that field, we're going to change that op flag there to I for insert. And we'll see where that's important. Let's follow the I insert down here. Then after row, which would get triggered after the user has inserted the row into the screen array, after row, if the operating flag is I, in other words, it was set to I, they did insert a new row in our screen array, then let's go ahead and insert that into the database. So after row, they've left the row, we're checking the operating flag, it was an I because they did an insert, we're calling insertCust and inserting that data into the database. If we looked at insertCust, it would be our standard insert statement for adding a new row into the database. Now when the operating flag is U for update, we're going to call updateCust and modify the data in the database based on their changes. So if we come back up here, we can see in this control block on row change, if the operating flag is not I, so it's not a new row, a new inserted row, then let the operating flag equal U. So imagine as we go into each row, we are identifying it with a flag, and as the user makes changes to that row, we are changing the flag so that we can, after they leave that row, we can call the right SQL to either update or insert or potentially delete that row that they have left. And again, so this is looking at both the use of all these control blocks to manage the sequence with which these different control blocks are executed. Again, they are not in a sequential order, but instead they're triggered as the user is working within the cells. So let's go ahead and run the program again, and let's just think about those control blocks while we work within this program. So my current position in the array right now is on this particular first element and the name field of the first element. And if I choose insert, I'm inserting a new row. So if I think about those flags that were being set up, I have temporarily have this set up. I'm not doing a full insert or setting it to I because the user may decide to cancel that, and I don't need to execute an insert statement if they don't confirm that insert. But if they do go ahead and insert and they add some data, and they leave that field, then that data with ID 350 will be confirmed and will have been sent to the database. And let's just confirm that by running it again, and you'll see our row 350 here that was added. Now it's not an inserted row anymore. Now as I'm in this row, I'm going to do an update, and the way I know that it will be an update is that as I leave this row, it's going to be an on-row change. If you've changed at least one field in this row. Now if I go ahead and run the program again, we'll see the changes that we made to that row have been confirmed. So the cursor is declared, we're refetching the data, we're looking at a fresh set of data here, and those changes were indeed confirmed in the database.